I'm a computer scientist, and I've been having a battle with the technology. Yeah. Okay, so I've changed the title of my talk, and I've made it a few parts. And I'm going to do a little bit of interaction, first of all. You've all heard of PeerWise, so I won't ask you about that. In my classes, I do what I call student modelling to find out more about my students, and I'm talking to you. So I'm going to ask you if you put your right hand, my system is right hand up for yes, left hand for no, both hands if you can't answer the question. I know that no hands means something terrible. Okay, so who has heard about learner modelling? Right hand if you have, left if you haven't. Okay, a lot of left hands, so I will take that into account. Curriculum mapping. Who's heard of curriculum mapping? Oh, that's a win. I wonder if we all mean the same thing. And who's heard of dashboards? Okay, cool. Okay, so I want to put the three together in a funny sort of way because that's the sort of thing I do. Okay, so why are we not proceeding? Okay. So first of all, though, I want to explain my rationale for user modelling before telling you what it is. So I want learners to be able to support their metacognitive processes using data from their learning. And I think PeerWise, I have read about it for a really long time. One of the earliest papers you gave at ACE, the Computer Science Education Conference, a while ago. I haven't actually dared to use it yet. And my classes are biggish, so I must say the last talk made me feel, oh, how terrible that we don't give that calibre of feedback to our students. I would love to. But what I would like to do is help students learn to self-monitor, reflect and plan. We know that these metacognitive processes are things that very good learners have. And we know that educational literature is full of failures in trying to nurture them. And I think that's partly because it's the sort of thing that, you know, you're not going to learn it in one lecture. It's the sort of thing that requires practice over a really long time and us valuing it and actually having it count. So if it doesn't turn up in the exam, it's hard to sell. So I can see a lot of reasons why we don't achieve it in our current education system, but our new university attributes, the 10 of them, include a lot on metacognition, so I'm sure it's going to be a win and we're all going to change that. But this is something I feel very passionate about because when learners use a computer, there's all this data sitting there. At the moment, it's mostly wasted and it could be helping. So I want to give you two examples of some learner model dashboards and I'll then slowly introduce what I think a learner model is. And I guess I should say to start with, computer scientists disagree on what a user model or learner model is, so that's good. So here is an interface that a student could get if they were learning a thing called SQL. In this reference here, Tanya Mitrovic, she evaluated in classes and found it improved learning. And I'll just highlight, so she's got this explanation here that green means you seem to show you understand something. Red means you've done something like a PeerWise question and demonstrated you don't understand, say getting it wrong. And white is stuff you haven't yet done. And so this is an overview of this whole course, and it doesn't really matter what the details are. A whole semester-long course has been broken up into 6 big ideas, and here's a way for a student to see them and then actually to use this to say, okay, well, I'm going to start practicing this. If you had a lot of red, clearly you know you've got to do something. If you've got a lot of white, it might be okay because we're not up to that bit of the semester. This interface doesn't really go into that, but maybe she explains it in her classes. Here's another one that I really like, again, from this paper, which I've given as a reference. And so along the top, if very small print, you don't want to read it anyway, it's just computer science, are all the learning topics for the semester for learning a programming language. And the green is how this learner is doing. And, you know, intuitively, we're all pretty used to reading this. More green means better. This is some group in blue that you're comparing yourself against. It could be the whole class like we do in our learner management systems. It could be all the students who've averaged high distinctions in their undergraduate career, because that's who I want to compare against. And we did work, I don't know how many medicine people there are, we're in a medicine room. I had a student who built models like this for med students, and we made 50%. The okay, they did multiple choice questions. If they're getting 50% right, we said, okay, it goes green. And they changed that to 80%. It made me feel so good. I thought, oh, I trust doctors. It's wonderful. And I do think we need to build systems that let learners make decisions like that and to surprise us. But anyway, this one now in the middle is showing how far I deviate. And I really like this. Now, this, in a sense, is a learner model. They've worked out a whole list of things here that are our learning objectives. I'm going to summarise this in a minute. And then we collect evidence from wherever we can get it, and we show it to the student. And I will just, the student has selected this particular bit, which is loops, and they can now see where they got their greenness from. They're doing very well on whatever these quizzes are. They've got a slightly less brilliant career on their examples, and their animated examples not so good, whatever that means. But presumably it means something to the students. In systems that I have built, but not as clear as this to share in this context, you could actually click on one of these and get a list of what you could do to fix it, which I would love. Now, what I want to emphasise here is this is the whole course. This is me as a student seeing the whole course. And I loved the last talk. And I know that I talk to my students about week 1, week 2, week 3, but I would like us to lift it to attach learning objectives so that rather than saying week 1, because I know week 1 was loops, we start having systems that talk about the learning objectives, namely loops, rather than week 1. Here are some other examples. They did lots of studies to say which ones work better. So how do we do this? And how would I love to see this fit into PeerWise? And I want to say the goal is to enable a student to see a big picture of their learning progress in a subject, but linking all their learning resources. And I also think, okay, I make courses that are too complex. Yeah, so there's weekly homework that's got to be brought into each class. There are some big assignments that they do in groups. There are little quizzes, God knows what, and they're even meant to come to lectures. So I've gotten that in my head, but I know when I talk to them, for some mystical reason, they don't. So how do we actually communicate to students this big picture? And to me, the user model or the learner model is the secret sauce that we could use. So before semester, what do? You define the learning objectives. We've kind of done that theoretically when we write our learning objectives, but some of that's a bit tokenistic, right? And in a way, I think I'm doing some work with people in medicine and looking at the fact that a lot of medical stuff doesn't get recorded. But if you actually make sure that the people recording it are able to see how it's used, they are more likely to record it. Duh. I mean, why would you waste your time recording information that goes into a mess of data that no one looks at? So I actually think that maybe we would write better learning objectives for our course curriculum if we knew that they'd actually be useful for something. Each one should have a level. I'm going to do more of this right hand. Who's heard of Bloom taxonomy? Right, left, right if you have. Sorry, right if you have, left if you haven't. Yeah, a lot of right hand. Who really thinks they understand it well? Right hand if you do. Yeah. Okay, so I'm going to declare my position. I worked hard with a guy called Ray Lister who has read the books properly, and I worked with him to build a teaching system to teach people how to do Bloom. So I've sort of, I would actually have both hands up because I'd have trouble answering it. Okay, but you try and associate a level. In the computer science, because we're a bit simpler, we don't use Bloom for our curriculum, our internationally defined curriculum. We just have 3 levels, 1, 2, 3. 1 is the bottom, 3 is the top. 3 is what we'd love every student to have. 1 is what we probably test on the exam, and 2 is somewhere in the middle. You could use anything you like, but you've got to actually communicate somewhere how much you want them to learn. Is it just recall, or is it application, or is it creativity, which of course we'd love, but it's too much to ask. And then you link all the learning resources. This is starting to look as though it's a lot of work, right? But if we have the right interfaces, it might be possible. So, when we're looking at, think back to that visualization I showed you, there was loops that he clicked on. That was lecture 2, right? And it was lab 3. And also maybe a bunch of PeerWise questions if they were suitably tagged. We gave them an interface. And you could tag the distractors as well, because you obviously want to know you got that concept wrong in the distractors. So during semester, we have to, I'll just put the aim up because we like to not have to rely on you remembering it. You collect evidence. It gets stored in this user model or learner model. And then we make them available in an interface like the one I showed you as a big picture. And I I'd like them to be able to then drill down on all these details. I'm sort of repeating. Curriculum mapping. Now, I don't want to go over time, but I will briefly touch on it because it's so hard. I had a PhD student who did work on this, and I'll be honest, we managed to put together a team of dedicated computer scientists from around Australia who got a grant, who cared deeply about teaching programming. And we couldn't get them to use his system. But when he used it, they were willing to check it. So this is not going to be the answer to everyone's problems, but he did map out a curriculum. I don't want to briefly touch on it. So here is the product of defining one subject, and you don't need to read the details, but this access is from the top level of what you learn in computer science across a full degree. So it's, it's very high level. And this is my subject showing how much at the top one, core one level topics, I've designed a subject I can see how much it covers each of them, which is nice if we wanted to actually understand a curriculum. Here's the interface. Please don't spend too long, but here is a topic from the curriculum that we're using, probably never written for this purpose, so probably not the right solution. And then we've got a thing to pick what, this is application level, the students who expect to achieve. Here's another one that's just knowledge level. And then he built this interface, which is for teachers, not for students, but anything that's for teachers, maybe we should share with students. So these are the Bloom levels, one to down from knowledge up to evaluation, the old Bloom. And the middle one is this green here is what the teacher intended. And, the middle one is what actually happened in the whole class. And the top one is what the teacher intended for top students, and what the dark green is what the teacher intended for bare pass students. So we then pour all the data we've got from the exam into saying, well, we hoped that they would perform at this level. What the hell happened? The interface actually lets you drill down more, but this is kind of the vision behind it. And here's another one, the same sort of system, but now against these high-level concepts. So my big picture is that if you have a dashboard like this, and I'd love to have it, that enables my students to see my whole course, including when I'm doing a new course next semester, which I'm going to use an e-textbook, maybe PeerWise. Lets them see the big picture and me to document it. But I honestly think from research we've done on other such interfaces, it'll have to have scaffolding. Otherwise, the learner won't understand it. It'll have to be personalised scaffolding that says, hey, look at this. Have you noticed this? And as I said, we've done other experiments. I'm sparing you the details. So here are my main points. I would love to see a way to connect learner modelling, curriculum mapping, and a whole subject dashboard with PeerWise. Okay, that's it. Thanks.